Hello, my name is Trevor, and this is the object that I chose to model for my 3D point cloud for the LiDAR project, but more specifically homework 7. So right now, what this object is, it's called a Little Free Library. It's right outside of Oakland Hall, and it's kind of actually really cool. You can take books and you can put books in. It's a lot of them are for kids, and it's an interesting idea. But anyway, so I chose to model this left one instead of the right one because it's a little shorter, but it looks nearly identical. It's just a matter of height, and so I can get a better view of the rooftop. And so that's why I chose to select this one. So some key features, there are some words right here, and this is a clear glass pane right here. And then you have just two walls which are pretty flat, but you can see this overhangs a little bit, and on the back side it's flat as well. And this door can open up and you can actually see books through. And so right now, as I'm talking, I want to move over into this because this takes a little while to load. But this is just the MATLAB portion. And I have a different folder, a testing folder for a new text file that I'll talk about a little sooner, or a little later. So I'm just going to get that going. Now, here is the actual object that I'm modeling. And this is the back side. This is the front side, and this is actually really interesting because the front side, as you move it up, you can actually see into the window, and there's actually some texture right here, or some displacements right here, and that's because of the books on the inside. And I made sure to get the handle, and I got some of the hinges as well. And then lastly, there's also the side, which I took right here. And this is actually a really helpful view. You can see that there's a lot of light right here, and there's this object in the way. And so not only is it blocking the view, and I could take it at diagonals, but I wanted to take it from the sides, at least from the beginning, because from the sides there was no interference at all with the lighting, except maybe a few different points, but from the right side there was actually a ton of light on that. And so even if I didn't need to model that side, it could still really interfere with the process of collecting data. And so at the moment I'm only taking the three sides and just accepting that there are limitations to this LiDAR design. Now, as I was modeling it, and I was trying to use the color picker Python code, but there were some points that still matched the color of the laser, and so I tried to change the HSV values, and so I was able to eliminate it, but when I did that, this line became very thin, or almost non-existent. And so especially at areas where it's like this kind of color, but also you can see I blacked out right here because this laser actually kind of touched this side, and so that really interfered with the data collection. And so if this was a really large scale project where there were a lot of different points or values that I was or a lot of different pictures, then this wouldn't be at all possible. And so that's one limitation of this. But because this is a smaller scale thing and I only had between 70 to 100 different images, I was able to go through, and not on all of the pictures, but I was able to go through and black out where I thought there was interference based off of the results of the data generation. And so because of that, I was able to significantly reduce the noise. And it just goes to show again that some of the limitations of these methods of modeling this. So this right here is the 3D point cloud. It looks like its rotation is only about halfway through, and so that's why I wanted to start it early. But right now you can see this glass square right here. Here's the stand that it's on. This is the bottom of it. Here's the left side, here's the rooftop, and then that side is the back side of the roof. And then you can see some of the texture on the inside, which there's not too much. I could actually go through and collect some more data on the inside of it, but you can see that it's hard to tell that these are books, but from the pictures that I've shown you before, now we know that they are in fact books. And so then this is also the right side that's coming around. Some key things to point out. Right now, these points on the ground that you're seeing, that's just blades of grass. I actually kind of wanted to keep that in there a little bit, but I'll probably have to remove it for the 3D printing portion of this project. But at the moment, I thought that was cool, and that would help out to kind of determine or gauge the height of where the ground is. And so if I could line all those up, then I would get a pretty reasonable z value for the height. And so, and the reason I had to do that is because you can tell that I was, the stand was on grass, and it was kind of on a hill, and so there was a lot of different z values, and so that I thought might help a little bit in allowing me to line everything up in the z direction. Here are a couple other points that may not belong, and so maybe I can filter that out as well in some way or another. But some things to note, you can see there's like a curve here, and that doesn't actually exist on the actual house. And it's not a perfect connection between the different walls and the different surfaces, and there are angles to it that I could continue to try to adjust and move it back and forth and just play a game of numbers, and I actually will do that eventually. But right now, let me just show you the code that I generated. So before, we were collecting all sorts of data, and it came in the form of these test results, which show all these different points, and there's so many 0, 0, 0 values. And so the first thing I wanted to do is filter out all these 0, 0, 0 values and speed up the process of creating the 3D point cloud from the data. And so if you look at the program that I have, the first thing I do is I say if the words just being the line of text, I could have changed that value, but if that equals 0, 0, 0, then we're not going to deal with it. So we're going to get rid of it. So that's through opening, I have one called back, one called front, and one called left.txt. And the one that I use for the left, I'm also flipping to the right side because it's actually the exact same form. And so that actually worked out really well. And again, that's going to be a read file. But the one that I open, I have it as an append file. And I called that New.txt. So what I do is, as soon as we filter out the 0, 0, 0s, that eliminates so many different points right then and there. And then we have these XYZ values. And so I had to translate into floats from the strings, and then from the matrix that is given up here, or that is collected right here through this line split, I'm able to pull the different information and add little offsets for the translation. And I don't have a lot of rotation right now because it is more complicated. I will look into how to do that for the final 3D printed model. But I didn't have time at the moment. But a couple times you can see I left like a negative right here, and so that actually completely flipped the x-axis. Earlier on, I have these two negatives, which flips the x and the y, and so it actually rotates it 90 degrees. Or this rotates at 180 degrees, the other rotates at 90. And then I put all these XYZ values back into strings and then write it to this new document. And I can demonstrate how that looks real quick just by hitting run. And right here, you're going to see a lot happening. And then really quick, just so that you can get a view of it, there are only 24,000 lines where the other individual ones were 40,000 lines. So it took 4 different walls and took half the amount of different points. Now this looks like it's done running. Alright, so you can see that there are some imperfections, and that's the technology. Part of that is I just haven't had a chance to complete some of the rotations and figure out really how to do that with the code. So there's more work to be done there, but I think I did a pretty good job overall, and I'm really happy with how it looks. Right here you can see the stand, and it comes up into like a tripod kind of shape, and I don't need to show you, I'll show you that real quick. But yeah, it comes up in this like tripod shape, so even that shows up, which is really cool. And I could even get more detail on that if I took time to model it from the underside, and then I could get the base of this structure as well, which might actually be really helpful for 3D printing. But again, if you look at it from the very top, this is probably the best view where you can see the limitations of this modeling, and there are these curves, and part of that is some of the original code that we took when we had to measure where the point was going to be on the screen in on the horizontal axis. And so because at some point they all get bunched up a lot, I think that is a big reason for this this curving right here. And I could be wrong, but I'd be interested to see if I can find a way to eliminate that, or now that I've processed the data, find a way to modify it a little bit, because it looks like I could just find a curve to it and find a way to make it more linear. So that'd be an interesting pursuit. But again, I'm really happy with the way this came out. I really like this view. I think it's the most helpful with the coloring. The other one just turned out all red, but that's just because of I think the object that I'm modeling. You can even see this roof overhangs, which it does in this as well. And so overall, I'm really happy with this 3D model, the 3D point cloud. You can't see much of the texture on it, like for the roof or anything like that. You can only see the form for the most part. But again, you can see the books on the inside, which is really cool, and the grass right here. Anyway, so this is my 3D point cloud. Thank you for watching this video, and I will be uploading my final model